Hi everybody, this is our second and last video for Chapter 6, Newton's third law of motion, action and reaction. This is a very short chapter with some key concepts. So our objective today is to explain why an action force is not canceled by the reaction force. And so you may be kind of confused if you're like, well, if the action and reaction are equal and opposite, why do objects move? They should cancel each other out. Maybe that's a question you've been kind of having in your head and you just haven't asked. So let's take a look at it. So section 6.5 in your book talks about, do action and reaction forces cancel? So here is the answer. If action and reaction forces are internal to a system, they cancel each other and produce no acceleration of the system. But if action and reaction forces do not cancel each other when either is external to the system being considered, and you're probably like, well, that's just as clear as mud, Mrs. Pound. Well, let's go back to this. We have taken a look at when objects are not moving. Let's say we're talking about the normal force and weight being balanced. And so we have weight going down and the normal force going up. But remember, both of those arrows were attached to the same object. So they were internal to the system because they're both attached to the same object. However, action and reaction forces are not attached to the same object. They are attached to different objects, so they're external to the system. If you're just considering, let's say we have a ball, a soccer ball, okay? So the soccer ball has, say, weight, like I was talking about before. It has its normal force and its weight force, okay, from gravity on the ball, and that is the system. The system is just the ball. And both of those forces are acting on the ball, so it's not moving and they're equal and opposite, okay? But let's say you walk up and you kick that ball. All of a sudden, there is a force that is external to the ball, with the ball being the system. And there is an action force from your foot, okay, and a reaction force from the ball, which are equal and opposite, okay, but they do not cancel because the action force puts a force on the ball and sends it flying. The reaction force puts a force on your foot and you can feel that force. And because they're not on the same object, they're not on the same system, that is why the ball can accelerate. And to clear that up even further, let's consider from section 6.6 the horse and cart problem. If a cart pulls back on a horse with the same amount of force as the horse pulls on the cart moves forward because, let's take a look at all of the forces on the cart and the horse. Okay, so here we have those equal and opposite pulling forces. We have the cart pulling on the horse and the horse pulling on the cart. Okay, so that's these forces here. They are equal and opposite and they look like they cancel. And this is the entire system, so we are considering them both in the system, so yes, they do cancel. Okay. We also have a friction force. We have the friction force that is equal and opposite here between the cart and the ground. And we have a force from the horse pushing on the ground and the ground pushing back. Now, because the cart and horse are the system, these cancel out. But because we're not considering the ground as part of the system, that is external to the cart and horse being attached to one another, the force of the horse pushing on the ground is actually what propels the cart forward and the horse with it, okay? The horse goes forward, the cart goes along with it. So it is not the horse pulling on the cart, It is the horse pushing on the ground that moves both of them forward. That is the key there. Okay? Without the ground, the cart wouldn't move because it's attached to the horse. But it's the horse pushing on the ground. So the harder the horse pushes on the ground, the more it will be able to move the cart. And actually, once it gets that cart started, um, it just, in fact, you know this, once you, it's really hard to get, say, like a really full wagon started, but once you get it started, it's really easy to keep pulling on it. Okay, and it is actually the act of you pushing on the ground that is pulling that wagon forward. So the answer to the question is F net acting on the wagon is greater than 0 because all we have to consider is that F minus F. So the force of the horse pushing on the ground minus friction is what is pulling the cart forward. Now, if you don't completely understand this, sit down, wrestle with it for a while, take a look at your book too, okay, if you need to. Sometimes these videos aren't enough. You need to look at more sources, so take a look at these sections in your book. And you know what? Newton had a really hard time with the third law, okay? So if you don't get it right away, that's okay, because Newton, who came up with it, didn't quite completely understand it either. It's okay to not completely understand something and to just know the facts about it, because you know what? One day you will understand it when you have more experience with it and maybe have looked at it another time. So, the last section in your book, 6.7, action equals reaction. According to Newton's third law, if you gently push on something, it will push gently on you. And I think I have this picture in the background because that's a good life lesson too, okay? Newton's third law can be applied to life as well. If you are gentle with others, they will be gentle with you. If you are harsh with others, they will probably be harsh with you. And so, use this as a life lesson. And you know what? The Bible even talks about that, doesn't it? Okay, so this is even biblical. So don't forget your 5 questions, and we are done with the chapter. So start studying, go on Quizlet, and we'll be taking a test soon.